Good morning and welcome, distinguished guest. First of all, we would like to thank you for taking out your valuable time and joining us for this insightful webinar. We are honored to have Mr. Prabhat Khare among us, a luminary in electrical engineering and management. His journey, marked by a gold medalist title from IIT Roorkee, is a testament to excellence. As a certified energy manager and life member of the National Safety Council of India, Mr. Khare brings a wealth of experience from esteemed autonomous bodies. Currently, as the Executive Vice President at Lithion Power, he not only drives innovation in the automotive industry but also contributes significantly as a subject matter expert in manufacturing at the Automotive Skills Development Council. Join us in welcoming Mr. Prabhat Khare, whose dedication to skill development and industry advancement is truly inspiring. Welcome, sir.
Only 70 parts which are welded together as of now. But in Model Y, they are planning to have a two-piece die-cast metal, the front and rear, and center will be the battery part of it. So the whole welding shop gets eliminated, and then the waste gets reduced. And at the end of it, when the vehicle comes for recycling at the end of life, because there's no joint parts, so you can straightway compact the body and melt it is pure aluminum which comes out of the thing. There are no spots, there are no welding, no joints. So this is pure aluminum which comes out if you melt the whole thing. So this is how it is was shown in one of the thing. This three-part castings. So it is a better recyclability index over the time compared to conventional vehicle. So this is a concept which this Tesla has brought in, and now Toyota is also trying to follow this, and slowly probably this will become a conventional, and all other companies will follow. So the recyclability of the white body becomes more better. Now, with EVs coming in, there is challenge of battery waste and battery recycling at the end of life. Not rather end of life, but maybe end of second life. From the vehicle, it comes out and then goes second life use, and then you recycle a battery. So Tesla is also one, because Tesla is a leading company in electrical vehicles. So they are redesigning the battery, and they about a year back or a year and a half back, they literally came out with a different kind of a battery. Conventionally, we use either 18650 cell in the current all Indian market. Everywhere it's filled by 18650 cell. Like Ola is going for 2170, which is second cell, but Tesla is going for a one step higher, which is 4680 cell. So it becomes much larger cell, and in the car, the number of cells becomes less for the same power, same energy. And this cell which Tesla is planning to make, it is 5 times more energy. It is 60. It will give 16% range more, and it will have 6 times more power. And the numbers will also get reduced. At the end of life, you suppose you have 18650 cell, they have about 300 or 400 cells in the car. So if you move it to 4680 cell, the numbers will become literally half or one third of that. So at the end of life, you have to handle only one third of those cells. So the few things will happen with this kind of improvement, that cell life will become more, handling of cell at the end of life becomes more convenient, and you have less wastage coming out of the vehicle at the end of life. Second thing is these tires. Tires are again a big challenge to handle because they don't decay with time. They don't rust, they just lie there. And this is one of the biggest challenge in automobile industry, that every vehicle, every maybe 20, 30,000 kilometers, you have to change the tires. So either you melt it, remelt it, recast it, but that is again a challenge, because in tires, today's tire, you have a steel, many things embedded into it. So the companies generally don't prefer to recycle it, and it goes in dump yard. So the challenge is how do we handle this kind of waste? And it is almost 2 to 3% of waste material of the automobiles, and about 1.2 billion tires are disposed of globally. Because every vehicle will have about 5 tires coming out on every 5 years or 6 years. So, but then there are people who are handling this recycling of tires. There's a girl in India. I saw the news sometime back. There's an Indian entrepreneur who makes slippers out of this tire. They take the tire, they retreat it, and then they make. But then this is very small consumption of tires, because when vehicle, well, from one tire you can make 20, 30 shoes. But then people have to find out a ways how to handle these tires and how do we dispose them out. This is one of the challenge. So in design part, till now, people are not able to find out an alternative for tires. How do we do it? So this is a part of planning and doing that. The people are still looking for it. Ki how do we handle this tire waste? This is one tire which had come a long time back. This is called airless tire. This was something of this kind. This was it came to way back in 2005, but then that time it was not popularized. I don't know why. It is without air and it has more life compared to conventional tires. So you basically increasing the age of life of the tire so that the waste comes out less. Again, Tesla is a company which has broken many barriers of the conventional automobile making. So this was again a trial out by tried out by Tesla in 2022. Then they just show a video. This is how they put that, tires in the car, and they're testing it so that then future cars they can get this tire. They tried it in Model 3 in 2022, and probably in times to come, they will be making it a standard part of their vehicles. So, they don't get puncture, they don't, they only age because of wear and tear, and that's why the life becomes more compared to conventional tire. So this is one part of planning. The automobile makers are considering for reducing the waste when the vehicle comes out for recycling. So the other things in planning is process efficiency in manufacturing. You improve everything, then do other things so that recyclability of the vehicle becomes more from the design part of a manufacturing part of it. Now, second part is check and act part of it. So I'll cover some of the check part is basically when you drive vehicle. So for that, let me explain what is an ecosystem of IC engine. I'll show a slide for electrical vehicle, which is more or less similar, but there's some differences to that. So if you have a automobile, talk about the whole system, ecosystem of automobile, it is you have a fuel system, you have manufacturing system, you have a regulatory system in which you control emission and all those kind of things. Then you have a operating system through which the waste comes out, liquid waste comes out, solid waste comes out. And the end of life, you have a treatment, and then it goes for landfill or it goes back to manufacturing system again. So this is
Okay.
Okay. And somebody was trying to speak, right? Okay. And then this whole system, we talk about the life cycle of IC engine and talk about this component. So at the end of life, roughly, it consists of this broadly these kind of material. I've taken average of cars, trucks, and on an average of whole automobile from internet. So if you talk about recoverability of these parts at the end of life, is about 87-85% of thing can be recovered. And broadly, it is copper, iron and steel, copper, thermoplastics, textile, rubber, glass, magnesium, and all those kind of things, gas and liquids. And if you talk about electrical vehicle system, there is slightly different operating system in this. Instead of fuel system, it has an electricity generation system, then have energy regulatory system and battery manufacturing system. And then end of life, you have a automobile recycling and you have battery recycling. So these two things become more critical compared to IC engine, where you only have to treat the vehicle. And in electrical vehicle, it is roughly battery constitutes about 40% of the waste of this vehicle, and about 95%, 93% can be recoverable if you do a thorough job, which I'll cover a bit later. So about 90% of items can be recovered. And in battery, if you talk about first lithium-ion cell, it is 96% item can be recovered. Case, cathode, anode, material, everything can be recovered. So battery can be recycled up to 96%. So this is all for batteries. With what you go to black mass and all those kind of things, you recover anode, cathode material. But the question is, why should a vehicle become, and why does a vehicle become obsolete? Why should it become an obsolete? Because wear and tear is okay, when the aging is okay, but then why should it become an obsolete vehicle? Now, that's the question I'm trying to summarize here. Some of the reasons how the vehicle become obsolete are, what's the first is natural aging, which is we all know that with the age it becomes old. Then there could be damage, there could be an accident, there could be a fire. So once it happens, then you can't use the vehicle. Then there is a irreparable technical snag. Suppose engine seizes, or there is some kind of a or in electrical vehicle the battery fails or motor fails. So it is not repairable. So the or repair cost becomes more than the vehicle cost. So it becomes obsolete. Then there possibility of non-availability of spare parts. Suppose some vehicle was made in 1970 and today you don't have a spare part, so you can't run it in case that part goes out of order. Then there is a theft, there is a stripping, people steal it, they cut it. So that also, and then leave it part of it, so it becomes a spare part. Then there is a natural disaster, earthquake, in that many things get damaged, lack of maintenance. Then environmental challenges are there, which I think we all know. We have this pollution control, emission norms are coming in India. The last one is that at certain point the vehicles can't be maintained. Suppose you have a 50 years old vehicle now, the maintenance cost becomes more than the vehicle cost itself. So these are the factors which lead to vehicles becoming obsolete. And if you summarize this, is most importantly is technology shift. And technology shift can be anything. So currently it is IC engine to electrical vehicle. Then there are safety norms. If you remember, in 20 years back, there were no safety belts, there were no airbags. But now you can't fly a vehicle without these two, at least minimum fitments in the vehicle. So the old vehicles you can't take it on road, and that become obsolete. Then new regulations keep on coming, and there could be many more. So over the time, many safety features have come in because of which the old vehicles have become obsolete. Laminated glass, headrest, brake, from mechanical to hydraulic brake to ABS to EBD. Seat belts have come in, padded dashboard has come in because of safety reasons. Airbags have come in, collapsible steerings have come in, ESC has come in, rear view camera, lane keeping assisted. So all those things have become mandatory in the current day vehicle. And if older vehicle they don't have it, government will not allow them to come on the road because they will become a safety hazard. So then you can't take out the vehicle. So what do you do with those vehicles? You have to go and get it recycled or sell it to some scrapper. This is just chart showing how the emission norms have come in India. So if you see the same chart of the vehicle growth, from 1995 onwards, the number of emission norms have started going up. In 1996, first norm of India has come in BS1, then BS2, BS3, BS4. BS5 was missed out. Then BS6 had come in between. Then RD has come in, and 2030 the new norms are supposed to come. RDE has come last year only. 2000, it has come 1 year earlier. It has come last year, 2023 March. It was supposed to come in 2024, but it's come only earlier. RDE is a real time driving emission norm. So any vehicle which is it has to record this emission norm data in its CPU, and government can check that performance anytime. So it is real time emission norm, especially for commercial vehicle. It has become mandatory. कार के लिए भी हो गया है ये. In fact, if you remember last March, April, there was a lot of issue from all OEMs because of this norm only. They had to modify the whole tailpipe emission system. So why do we recycle a vehicle? We saw that the vehicles become road unworthy. So you try to take out the material and then go back to the loop and then try to reduce the virgin material and feed to the industry so that you draw less from the nature. And also there are many hazardous material into automobiles. You have oil, you have gases, you have refrigerant gases, you have many other things which, if you leave it open in the atmosphere, they will damage the soil, water. They will lead to contamination of this everything, even human health. So they have to be taken out properly and they have to be contained somewhere. So that's why this recycling has become a important. And with the numbers going up again, the numbers of the complication is increasing. In India, roughly 12 to 18 million vehicles reach their end of life every year. Um, and about 70% of metals, because that's what we saw, 70% of material can be recovered and put back to the industry. There's a report from CSE, there's an NGO called Center for Science and Environment. It came in 2020. And it says that by 2025, I don't know how accurate these figures, but about 1 lakh 18, about 1 million or 1.2 million vehicle will be coming out of commercial vehicle, and then 22.58 million vehicle will be coming out of for scrapping. They will be coming off the road. Now, if you compare, and out of this, about 9.12 million ton of steel can be taken out. Now, this is a figure which is worth noting. Now, if you take out 9.12 million metric ton of steel from these kind of a old vehicle, this is roughly 7% of India's production of 2021. We produce about 130 million ton of steel in 2021. So about 7 to 8% of that steel. So this much of raw material can be saved when you do a recycling of automobile with a proper system. So that's the impact on commercial part of it when you talk about recycling of automobiles. This is one example, but then you can extend it to any other material also. You have copper, you have foam, you have plastic, you have a tire, you have glass. Percentage can vary, but then this is a kind of a weightage you have. Now, when you talk about recycling, people think that this is only kind of you just take out the vehicle, dismantle thing, and then put it somewhere that people are not aware of it. So I'm just trying to make a flow chart. This is how it happens. But it should happen rather. You have vehicle which comes out, then you remove the good parts. Probably it doesn't happen in India. It is not allowed properly in India, but other countries it does happen that you take out good parts, refurbish them, and then sell them as a genuine spare parts for secondary use. These parts are generally primarily they are non-functional parts. Like you have a seats, you have bumper, you have dashboard kind of thing, or maybe a handrest, or anything. But in other countries, they also do refurbish engines. They do refurbish shock absorbers. They do many other things which are functional parts. They are certified, tested, and then resold as a genuine spare parts for secondary use. Sometimes people take out some material and use a decorative item. This is a art piece kind of thing. That is some people do it. Then steel, material, copper, they separate out. It goes to scrap metal market, goes to steel processing unit, and it goes as again comes out as a steel egg knot. Gases, other things are retrieved and reused. Rubber is taken out. Discarded tires are again you dismantle the rubber lining, steel part of it, and then recycle, retread it, and then either you sell it as secondary tire or you give it to tire company for recycling. Glass is again taken out. It goes to glass processing unit, and it goes as a virgin material. Plastic items which are good again go out as a spare sold as spare parts. So broadly, this kind of a thing happens when you talk about automobile recycling. But unfortunately, what is happened in India, because numbers were stagnant till 1990. There was no market for recycling, so it was left to some kind of a unorganized sector, which was taking the vehicle, cutting it out in open, and then dismantling it. Probably you must have heard of name Mayapuri in Delhi, which is known to be world's biggest graveyard of automobile actually. So this all manual process, no automation was there. It was all done manually. People were cutting it with bare hands, getting exposed to oil, getting exposed to different kind of gases. But then slowly things have started improving in last 10, 15 years. Probably 2018, the things started changing in India when government created a portal on e-Parivahan kind of a thing. There is a scrap portal which is not very perfect portal, but then it gives certain information. You can find out the people who are recycling the vehicle. There is a list of people. So it's called RCVF kind of thing. So they have put up manual how things should happen. And these are the some companies, not some companies, 48 companies are in India as of now registered to handle vehicles. They called RVC SF, registered vehicle scrapping facility. They are in operation. So this details of these companies can be taken out from that portal, the contact number, the contact person, so people can approach them. So this is a list. I'm just sharing the list. People should know that this is the state-wise list of UP has 13 number of these agencies who are operating as a vehicle scrapper. Haryana 9 and this kind of setups are there. And these are the plan one, which are approved but not in operation. The green ones are in operations. So total about 48 RVSFs are in operation. 46 are in process of getting operational. But again, let me share how a vehicle recycling happens in advanced countries. This is what we saw there before. So this is a broad kind of thing which you take out material, you do, and then this is India. We saw that master one. This is what happens in India in these companies, which we call it RVSF. They do first level of scrapping. They take the vehicle, dismantle the vehicle, and give it to secondary agencies who treat the metal at a next level. So there's nothing like integrated facility in which vehicle goes in and comes out as a different metal. So this will there are challenges because its recycling is done only at first level only. Uh, Dismantling is done properly, everything is done properly, but then after that, the handling of second level of treatment is not there in India. It again goes to unorganized sector, or probably somewhere it might be having organized sector, but as far I understand, it is 80% unorganized sector which takes the metal from these RVSF and then handles them. But if you compare to like Toyota is one of the company which has taken this recycling facility to services to a extreme level. So I'm just sharing a flow chart of Toyota in which the vehicle comes for recycling, and it is only their vehicle which come. They don't handle other vehicles. They handle only their own vehicle at the end of life. So vehicle comes for scrapping. They take out the metal, ferrous metal, non-ferrous metal. Then they go for auto shredder. And this is a facility which we also have in India. When we talk about RVSF, this is a facility we all have in India. Most of these RVSF have this kind of a setup. Toyota takes it forward in the second stage. And at this level, you usually recover 70-75% of material. Toyota takes it to second level. They call it ASR, Automobile Shredder Residue Recycling Plant. Now here they do second or third level of treatment in which they take out everything. Aluminium is separate metal, non-ferrous metal, glass separate, urethane foam separate, copper. They go up to the metal level and then take out. So it is about 95% of vehicle is 85 to 95% they can recover the metal. So this is what is missing in India. ASR facility is not there. Probably it will come in time. It is too early in India. And when you talk about battery electrical vehicle, then there is a dedicated battery recycling plant has to come up along with the main battery recycling plant, which probably, as far as I understand, in India, there is nowhere it is available, battery recycling plant, because batteries have not started coming in for recycling. And then you take out good mass and go up to the black mass and recover the basic metal from the battery. So this is yet to come. People are working on it, but then probably it will take another more than 5 years to come in. So this is what is missing in India. This is still not there, the red box. Some challenges in creating circular economy in India, because there are no standard guidelines for auto OEM to their supply chain, because everybody has ISO 14,000 or whatever standards they have with the OEMs. They manage it till the tier 1, tier 2 supplier, but then going up to the last supply chain, it is very difficult in India, because many times the last person in supply chain probably is a kind of a SME kind of agency which may not be following any environment regulation. So it becomes a challenge. there are no properly integrated system to track account for non-functional vehicle. Now it is starting. It was not there, but now with the new number plate system, the HRCP, they call it high security HSRP, high security registration plate. Now they know which vehicle is made which year, and then it is more computerized. So RTUs are becoming more progressive in tracking the vehicle's age. But then we need to integrate many database like RTO, FASTag, insurance policy, all those insurance system. Those things have to be integrated, and probably these things are moving in this right direction for this in India. No transparency in operations of existing auto shredding recycling facility for public awareness. Now, this is a point which I've been raising everywhere. In fact, there's a Bharat Mobility show where there was a stall for all these recyclers, but they don't allow people to come in and see what they are doing. When we were making vehicles, we used to show the plant to the people who will come and see how the vehicles are made. I keep suggesting that people should be allowed to come and see how the vehicles are recycled, how what is being done to their old vehicles, so that people are made more aware and they are willing to give their old vehicle for recycling, knowing well how it will be treated. Again, when we talk about recycling of vehicle, then there's some parts which can be used. They need not be scrapped. They need to be refurbished and reused as a secondary market. Suppose I have a vehicle which is 5 year old, and I need a bumper or need a headlight. I need a seat for that vehicle because of certain issue in my vehicle. So why should I buy a new one? Because they are not functional parts. So I can go to a secondary market and from any recycled vehicle from where they have taken out these material, I can buy it at lower cost. And this will not impact the performance of my vehicle, neither performance nor safety. But that system is not available in India. There is no agency which can certify, okay, you can use this part. There is no. Globally, other countries, there are agencies, there are companies who do this kind of thing. Similarly, there are no. I have not heard. I have not seen anybody talking about ASR kind of facility. We talk about that first part of Toyota, which is recycling shredding facility over there. There is there, but going to second level of treatment, where you extract till metal level, that plan is not there. Probably that is too costly. But then sometime in near future, we need to start thinking of ASR, uh, which had to come to improve the recyclability of these vehicles. Again, there are no plans to create special landfill sites for ASR residue, which is again a very dangerous kind of a thing, very hazardous, though very small quantity, but it's hazardous material. So we need to create a special landfill site. Currently, probably whatever is left out, it goes to normal landfill site. But probably when we talk about ASR, we need to create a second, more improved landfill site for these burying these kind of a thing. बैटरी का अभी तक कुछ भी शायद इंडिया में नथिंग has started. Probably it is too early. Batteries will start coming in 10 to 5, maybe 10 years down the line. So it's still time to go. So let's see how does it move forward. These two videos come this end of the slide, so I'll just show you two videos how it is done in India, how it was done in India, and probably Mayapuri. I'm showing a video which was done till 5 years back. Now it's still they handle the vehicle, but they take it from RBCF kind of thing. They dismantle and it goes for thing. But that was situation in India, and one is for a Canada video. How do they do it? I'll play both the videos together so to save the time. This is India, Mayapuri. It is called biggest graveyard. It was, or it is still a biggest graveyard of automobile in India. You just compare how the thing in advanced country and how we were doing till 5 years back. Few things have improved in India, but it is not as good as other advanced countries, because in advanced countries they have been doing it for quite some time. But it's almost, I think, 30, 40, 50 years they're doing it. So if you see this Karakone's Kannada video, they are tagging each component which is reusable, and then they are sold as a secondary part to the second market. When engine, gearbox, shocker, everything is the tagged, numbered, and with age life, it is sold as a second market, certified second-hand market kind of thing. And in India, see, if people handle this kind of thing by hand without safety precautions, they are exposed to and number of diseases. They are exposed to hazardous material. The medical issues are there. I don't know whether you're getting the voice, video, or sound or not. I'm not sure. I'm not getting the sound.
So the sound is not there.
Now I don't know why it is not there. Okay. Probably now it is coming, right? This is how they repair the bumper, make it probably record, keep it, and then paint it, repaint it, and store it to sell it in the second market. This is tire rim. Tire rim is again refurbished and sold in the secondary market. Well, many components are taken out and then restructured and sold in the market. But in India, we have not started this kind of a business. So this is it. This ends my thing. Probably 45 minutes was okay. A bit early.
No, I think it's pretty good and a lot of details, though many technical things we would have, but we cannot understand the technical side, but it gives a very good overview of what's really happening in automobile. And
Any question? I can take it in between. Case.
Somebody is asking for the PPT if you would be willing to share. So we'll share the recording, but okay. So also in terms of, sir, a general question which we keep hearing about EV is the future. Do you think EV is the future, or there'll be a balance between EV and
there has to be balance because whatever you call it, I have grown up in IC engine atmosphere, so till they get a better alternative of gasoline fuel on the fossil fuel, has to be balance. You can't be purely on an EV. And secondly, EVs. By EVs, what you're doing, you're shifting till you have a green electrical energy from solar, wind, or whatever way. You are shifting the pollution from cities to a centralized place where you generate the power. So probably the many studies which show if you take full life cycle assessment of EVs, it is more dangerous than an IC engine. Only advantage is that it doesn't contaminate the society when it moves around.
Okay.
IC engine contaminates the whole society because of emission and other things. But if you take whole life cycle from battery raw material to mining of the lithium thing, whatever, the whole life cycle, if you take, the electrical vehicle creates more environmental, impacts, degenerates environment more than IC engine.
Okay.
But society, it doesn't. In society, it gives a better place to live for public because you can shift the whole thing to a corner. Whole emission, whatever bad things are there, shift it to there. And second, the electricity has to be a green electricity. Otherwise, if you generate coal somewhere and then generate a city and then use an electrical vehicle, it is a wastage of thing. You burn fossil fuel actually, and then generate electricity and then use EV, then that's not thing. But you need to find out a balance.
So also with coming of ESG, do you feel because in so many years we've not been able to regulate this entire recycle, we are just outsourcing. I think companies are just outsourcing it and
Yes. So but it will
getting it
take time
done.
because till 2018 it was nothing. There was nobody actually. And Mahindra Sero was, I think, first company which opened up in India 2018. And now at least you have 48 companies and then 48 operational recycling plant. So first level is already started. And probably in times to come, second level, third level will also come.
So again, it's a huge investment, I believe, which companies will have
But
to.
I understand. I was speaking to somebody who operates one of these RBCF, and it's a very profitable business actually.
Mhm.
It is because the investment is very low. Matlab and then your return on investment is very high. The metal cost itself, metal, steel, everything.
Right. Okay.
But just because it is you're handling a scrap, people don't
Mhm.
give that respect to you. Well, probably that
Right.
is a more challenge actually.
True, true. But if you see the Canada video, I think a lot of respect can come if it's
Yes,
done in
yes,
such a
yes, yes.
structured manner.
Uh,
Yeah. I believe Rahul has raised his hand. Rahul, you
Yeah,
can unmute and ask.
thanks, madam. Thanks, sir. It was a really insightful session. My question is about this EV. So,
hmm,
as we know that with EV, there is a lot of hazardous waste we are going to create, and
hmm,
disposing of or recycling the
hmm,
hazardous waste is going to be a major challenge which we can see. So,
hmm.
how do you see this hazardous waste would be recycled? Because tires, you rightly mentioned, it is very difficult to reuse. Likewise, the lithium ion or other kind of batteries, those will be coming in.
But EV में the batteries generally the battery life what people companies are giving is 8 to 10 years, right?
Yeah,
So and that too after 8 years it is not zero. Generally at 70% or 80% of energy content they take out from mobility market, and then it can use a secondary application. You have a stationary, you have energy storage devices, you have a power bank, you have UPS. So again 10 years more you can use the batteries, about 10 to 15 years. So the battery pack which is made today will be available for scrapping after 25 years.
okay, not
Now,
not
now
so.
in that 25 years also, the battery pack per se will not be, whole battery pack doesn't go waste. One, two
Mhm.
cell or five cell or 10, well, out of 200 cell, maybe 50 cells will go bad.
Okay,
So those things have to be recycled. Yes, there are challenges because these cells will have certain energies. So first they have to discharge. In fact, currently people are handling laptop batteries and the smaller
right,
batteries. People are handling it. So same technology, same skill can be upgraded to a much bigger level, and we need to build up now. Probably Punita ma'am can tell. Automotive Skill Development Council and their ESSCI, they started working on this kind of thing. So probably it take time to build that skill. But it's again is capital intensive because handling a vehicle scrapping is different part, battery scrapping is different part because that requires a lot of chemical processing.
correct. Mm.
But if you do it, you save a lot of raw material costs. You can again recycle that material in making fresh batteries. So India probably need to do it. But that has to be done.
Okay.
Thanks, sir.
So one more question, last question maybe, and if anybody else has. So you are connected to so many organizations, you advise them on this. And you are also aware what the regulators are thinking and where they are on this. So do you see any shift happening with sustainability now coming in? The pressure from regulators or companies now taking it more seriously. So,
And the companies are too taking it seriously. I remember I was in Honda. I'm telling about 98, 2000. Well, these global companies, when they come, they bring certain good practices with them. So, and probably now I think everybody does it. There was engine coolant which is used. Earlier, you had to replace engine coolant. I think every third servicing or fourth servicing, you had to replace the engine coolant. Now, Honda had brought in that time. I think that was first in 2000 that it was a closed circuit coolant. It was for lifetime. You don't have to change the coolant. So the waste gets eliminated for the life of the vehicle. Same thing for the AC gas. Earlier they were using 134. No, earlier they were using Ferron something in cooling. Now they have 134A and then R20. That kind of they're restricted to green gas for the for air conditioning of the cars. But like tires, like foam, like PVC, you can't get away with those kind of things. You have to handle those at the end of life. You have to treat them.
Yeah, because some examples you were sharing about Tesla and Toyota, I think, I mean, if those companies can do, I think others can also
Huh,
replicate.
but challenge is that if people have put in a lot of money conventionally on a certain processes like welding shop, they have put in, they have put 1,000 robots to make it, and they put press shop to support the weld shop. Now they can't get away with that actually. The capital intensity is so high. Tesla could do it because Tesla was a new company. They did not have any baggage.
True.
So that's why they could do it. They could change the whole process again, from the basic thing.
Right. Yeah. Also, it's a mindset, I would say, if a
His mindset.
company, yeah,
Because this
how you
process which Tesla is
begin.
following, it was known in 1900 also. It
Right.
was not that it's something new he has found out. It was known that time also, but it was not done, but it is not taken forward because that political, whatever economical reasons. Same thing, like electrical vehicle. They were much ahead in technology. In 1900, they were leading the automobile market before Model T came from Henry Ford, and gasoline was found out. Gasoline appeared in the market in 1908 or 1906 something, the 1906. Before that, electrical vehicle was ruling the market. But then gasoline had different set of political issue links. So everybody had something. So they got phased out electrical vehicle, and Henry Ford Model T, oil lobby, and then all those things pushed IC engine in the market. If you read
And
many books
so,
on the, I can share the books that they describe this whole political shift, how IC engine phased out electrical vehicle in 1900.
okay. And also these recycle plants, I mean, does government encourage with any incentives or any, so people set
Probably
up
no, but then they give some. It is commercially viable in the sense that then
profitable?
I'm not sure what kind of incentive gives it, but then they are authorized to issue some kind of certificate to these people, and government gives. It's like they are tradable certificates, like energy certificate and all those. Suppose you take your Maruti 800, there they'll give you some certificate of recycle value of 1,000 rupees. You can trade in the market that people buy it 40,000, 50,000 rupees, and then that business is
Okay.
thriving. That kind of
Okay.
thing.
Yeah. Okay.
It's tradable. It is not that if I have sold my vehicle and I have a
Mhm.
certificate, I need to spend. I can sell it to you also.
Okay. And Vipin has a question: how much energy we have to consume in recycling?
But that depends. But that is a very broad question. It's something like how much energy you spend on making a vehicle, right? It is same thing. It is what kind of facility you have, what kind of a thing you have. I remember when we were making Honda City car and Honda, we used to spend about that time. I'm telling about 2005-6 का बता रहा हूँ data होगा मेरे पास. You spend about 2,000 units of energy per vehicle, 2,500 units of vehicle in making. Uh,
Okay.
but dismantling will again. But then the plant was not full-fledged plant. It was there's no press shop. There was no many shops were not there. It was only welding, painting, engine, and it was not a fully integrated plant. So it depends what kind of facility you have, what kind of equipment you have, and what capacity you have. So if you have like 10 vehicle dismantling per day, probably energy cost will be high. If you have 100 vehicle per capacity, it depends on many factors actually.
True, true. Okay. So, any other question? Otherwise, I think we can wind up for today. So, thanks a lot, sir. I think it was
Yeah.
very insightful, and it's really opened our minds towards this about automotive, which we were not aware. So, thank you all so much for coming in. Thank you once again, sir.